Here are 20 practice problems on inferences and margin of errors. As per usual, I'll put the link to these questions and their answer key in the description. So if you want to work ahead, you can go and do so. Or if you need a little bit more help, I will be going through every single question. And if you still need further clarification, you can always shoot me a DM. Alright, anyways, let's get started with question number 1. I'm gonna skip all that. Alright, here we go. Based on the data from the study, an estimate of the percent of US teens who are heavy texters is 30%. And the associated margin of error is 3%, so our margin of error is 3%. Which of the following is a correct statement based on the given margin of error? So if you remember how to work with margin of errors, we're gonna add 3% and subtract 3% from this right here. So 30 plus 3 is equal to 33, and 30 minus 3 is equal to 27. That means that our range could be anywhere between 27% and 33%. So let's look at our answers. Approximately 3% of the teens in the study who are classified as heavy texters are not really heavy texters. No, that's not how margin of error works, so that's not what that 3% means. It's not going to be A. It is not possible that the percent of all US teens who are heavy texters is less than 27. So yeah, 27%, that is our minimum in our range. However, you cannot just straight up say it is not possible, alright? You cannot for sure 100% say that it's not possible. So our answer is not going to be B either, alright? You can never say anything for sure with these types of studies. And C, the percent of all US teens who are heavy texters is 33%. Well, we know that it could be anywhere between 27% or 33%. And once again, just straight up saying it is, you can never say something 100% for sure. So it's not going to be C either. And then D, it is doubtful, so that's already sounding better, that the percent of all US teens who are heavy texters is 35%. And if we look at 35%, that is outside our maximum. So D is going to be our answer, because saying something is doubtful is a lot better than saying that is 100% no, alright? Well, you know what they say, never say never. Question number 2. There are 55 students in Spanish club. A sample of the Spanish club students was selected at random and asked whether they intend to enroll in a new study program. Of those surveyed, 20% responded that they intend to enroll in the study program. Based on this survey, which of the following is the best estimate of the total number of Spanish club students who intend to enroll in the study program? Alright, this one's pretty easy. I mean, to find that, all you have to do is multiply this 55 students right here and this 20%. So 55 times 20% is just equal to 11. So our answer is 11. Question number 3. A researcher interviewed 411 randomly selected US residents and asked about their views on the use of nuclear energy. The table above summarizes the response of the interviewees. If the population of the United States was 300 million when the survey was given, based on the sample data for the 411 US residents, what is the best estimate in millions of the difference between the number of US residents who somewhat favor or strongly favor the use of nuclear energy and the number of those who somewhat oppose or strongly oppose it? So, first thing, let's find out how many people somewhat favored or strongly favored. So these two, let's add these two up and we get that is 270. And then those who somewhat opposed or strongly opposed are going to be these two, and add that up, we get 141. So if we find the difference between these two, 270 minus 141, we're going to get 129. Now, this table is only out of 411 randomly selected people. So 129 out of 411. Now, we want to compare this to the entire population of the United States, which is 300 million. Now, since they want us to give our answer in millions, that basically means that we can cancel these millions out. So you really only need to multiply this by 300. And then, if we go ahead and multiply this out, we get that our answer is going to be 94.16. And of course, they want the best estimate over here. They want us to round our answer to the nearest whole number. So our answer is going to be 94. Question number 4. A city has 50 city council members. A reporter pulled a random sample of 20 city council members and found that 6 of those polled supported a specific bill. Based on the sample, which of the following is the best estimate of the number of city council members in the city who support the bill? So from here, we know that 6 out of 20 random people, 20 randomly selected city council members, decided to support the bill. But of course, we want this out of all the city council members in the city, so we're gonna multiply this by 50. And we get that this is equal to 15. So our answer is C. Question number 5. The study was blah 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 blah. Alright, the sample contained 150 largemouth bass, of which 30% weighed more than 2 pounds. Which of the following conclusions is best supported by the sample data? So from what we got, we know that 30% of the largemouth bass weighed more than 2 pounds. The majority of all fish in the pond weigh less than 2 pounds. Well, I don't know about all fish, because here it only talked about largemouth bass. So it's not going to be A. B. The average weight of all fish in the pond is approximately 2 pounds. Once again, I only know about largemouth bass, not all fish. C. Approximately 30% of all fish in the pond weigh more than 2 pounds. Once again, only know about largemouth bass, don't know about all fish. And then C. Approximately 30% of all largemouth bass in the pond weigh more than 2 pounds. And yep, that's exactly what this little last sentence said. Oh, I guess that's the second line. Anyways, that's what that says, so our answer is D. Question number 6. A park ranger, let me skip that. Based on the responses, the estimated mean was found to be 4.5 miles, with an associated margin of error of 0.5 miles. Which of the following is the best conclusion from these data? So we have our margin of error, which is 0.5. That means we're going to be adding and subtracting that from 4.5 miles. So 4.5 minus 0.5 is equal to 4. And then 4.5 plus 0.5 is equal to 5. That means that our mean distance of miles could be anywhere between 4 and 5 miles. Alright, but remember, it's the mean. So let's look at it 8. It is likely that all visitors hike between 4 and 5 miles. And yeah, that does match our range. But once again, remember that our data is talking about the mean distance. So it's not going to be A, because it doesn't talk about the mean. And then B, it is likely that most visitors hiked exactly 4.5 miles. Once again, not only does this not talk about the mean, it could also be anywhere between 4 and 5 miles, not just exactly 4.5, it could be 4.1 or 4.2, and so on. C. It is not possible that any visitor hiked less than 3 miles. Once again, this doesn't talk about the mean, and yeah, 3 is outside our minimum, but you can never say it's 100% not possible. You could always be like that one weirdo that's different or something. I'm a lone wolf. Anyways, not C. And then D. It is plausible, so it's already sounding nice, that the mean distance hiked for all visitors is between 4 and 5 miles. So yep, that's true. It says it's plausible, it doesn't say 100%. It talks about the mean distance, and it is within our range here, so our answer is gonna be D. Question number 7. A sample consisting of 720 adults who own televisions was selected at random for a study. Based on the sample, it is estimated that 32% of all adults who own televisions use their televisions to watch nature shows, with an associated margin of error of 3.41%. What is the most plausible conclusion about all adults who own televisions? So once again, we have our margin of error, so we're going to add and subtract this number from 32. So 32 minus 3.41 is equal to 28.59, and then 32 plus 3.41 is equal to 35.41. So our range is anywhere between 28.59% and 35.41%. Now let's look at our answer choices. More than 35.41% of all adults who own televisions use their televisions to watch nature shows. Well, that's not inside our range at all, so it's not going to be A. B. Between 28.59 and 35.41% of all adults who own televisions use their televisions to watch nature shows. Yep, that aligns with our range here and also aligns with the watch nature shows in the text, so B is our answer. C. Since the sample included adults who own televisions and not just those who use their televisions to watch nature shows, no conclusion can be made. Well, they want the conclusion about adults who own televisions, not about adults who use their televisions to watch nature shows, so C is just a whole bunch of babbling. And then D, since the sample did not include all the people who watch nature shows, no conclusion can be made. This is also a whole bunch of babbling, because they only want the conclusion about those who own televisions. No one cares about those who watch nature shows. Question number 8. A random sample of 50 people from a town with a population of 14,878 were asked to name their favorite flavor of ice cream. If 7 people in the sample named chocolate as their favorite ice cream flavor, about how many people in the town would be expected to name chocolate? So here we know 7 out of 50 people in this sample chose chocolate as their favorite ice cream flavor, which honestly should just be wrong. Like, I thought we all grew up from chocolate since we were like 9 years old. Anyways, then we need to scale that up to 14,878 people, which is our total. So multiplied by 14,878 gets us 2,082.92. And the one closest to that is B with 2,100. Question number 9. A bag containing 10,000 beads of assorted colors is purchased from a craft store. To estimate the percent of red beads in the bag, a sample of beads is selected at random. The percent of red beads in the bag was estimated to be 15% with an associated margin of error of 2%. If R is the actual number of red beads in the bag, which of the following is most plausible? So once again, we have our margin of error of 2%, which means we're gonna add and subtract 2% from 15%. So 15 plus 2 is equal to 17. I think I've been doing minus first, I don't know why I changed it up. And 15 minus 2 is equal to 13. So our range could be anywhere between 13% and 17%. However, here they didn't do it in percents, we have to actually find it out. So I do have desmos here, and I just want to show something real quick. That you can just do 13% of, yeah, if you click 30%, like of just pops up, and then you can put 10,000 here, and you get 1300, and then you can do 17, and you type in percent, and like puts in the of for you, and like I think that's real cool. Anyways, our range is gonna be between 1300 and 1700. So let's look at our answer choices. R is greater than 1700. Well, that's not in our range, so no. B, 1300 is less than R, which is less than 1700. Weird way to say it's between 1300 and 1700, but yeah, that's our answer. C, 200 is less than R, which is less than 1500. Yeah, I don't know where they got 200 and 1500 from, but no. And then D, R is less than 1300. Once again, it's not in our range, so no. Question number 10. The results of 2 random samples of votes for a proposition are shown above. The samples were selected from the same population, and the margins of error were calculated using the same method. Which of the following is the most appropriate reason that the margin of error for sample A is greater than the margin of error for sample B? Now, if you remember, the greater a margin of error, it's usually going to be because it has a smaller sample size. Smaller sample size. And then a smaller margin of error usually results from a larger sample size. So the reason this margin of error is greater is because it had a smaller sample size. And the one that says that is D. Question number 11. From a population of 50,000 people, 1,000 were chosen at random and surveyed about a proposed piece of legislation. Based on the survey, it is estimated that 35% of people in the population support the legislation, with an associated margin of error of 3%. So margin of error of 3%. Based on these results, which of the following is a plausible value for the total number of people in the population who support the proposed legislation? So here we have our margin of error, and we're gonna go ahead and add and subtract that from 35%. So 35 plus 3% is equal to 38. And then 35 minus 3, well, why am I doing backwards again? Is equal to 32. That means our percent can be anywhere between 32% and 38%. Now here, they don't actually ask for the percentage, they're asking for the total number of people in the population. So it's gonna be out of these 50,000 people. So we're gonna do 50,000 times 32%, which is 16,000. And then we're gonna do 50,000 times 38%, which is 19,000. That means our range could be anywhere in between 16,000 and 19,000 people. And the only answer choice that fits that is gonna be C. Question number 12. A certain forest is 253 acres. To estimate the number of trees in the forest, a ranger randomly selects 5 different 1-acre parcels in the forest and determines the number of trees in each parcel. The number of trees in the sample acres are 51, 59, 45, 52, and 73. Based on the mean of the sample, which of the following ranges contains the best estimate for the number of trees in the entire forest? So, the first thing we're going to have to do is find the mean of these numbers. So I do have desmos open here, and I'm going to name my list L equals 51, 59, 45, 52, and 73. And then the mean of L is 56. So our mean is 56. Now we're gonna have to multiply this 56 by 253 acres. So we covered the entire forest. So 56 times 253 is 14,168. And the only range that covers this is C. So our answer is C. Question number 13. At a large high school, 300 students were selected at random and were asked in a survey about a menu change in the school cafeteria. All 300 students completed the survey. It was estimated that 38% of the students were in support of a menu change, with a margin of error of 5.5%. Which of the following is the best interpretation of the survey results? So here we have our margin of error of 5.5%. So we're gonna add and subtract that from 38. 38 minus 5.5 is equal to 32.5. And then 38 plus 5.5 is equal to 43.5. That means our values could range anywhere between 32.5% and 43.5%. Let's look at our answer choices. The percent of the students at the school who support a menu change is 38%. Well, that doesn't cover our entire range, so it's not A. B. The percent of the students at the school who support a menu change is greater than 38%. Once again, that doesn't cover our entire range, so it's not B. C. Plausible values of the percent of the students at the school who support a menu change are between 32.5% and 43.5%. So that is right, so our answer is C. And then D. Plausible values of the number of students at the school who support a menu change are between 295 and 305. So let me go ahead and just calculate that and see what it actually would be. 32.5% of 300 would be 97.5, not 295, so it's not going to be D either. Question number 14. Based on a random sample from a population, a researcher estimated that the mean value of a certain variable for the population is 20.5, with an associated margin of error of 1. Which of the following is the most appropriate conclusion? So once again, we have our margin of error, so we're going to add and subtract that from 20.5. 20.5 plus 1 is equal to 21.5, and then 20.5 minus 1 is equal to 19.5. So the range of our mean values is anywhere between 19.5 and 21.5. Now let's look at our answer choices. It is plausible that the actual mean value of the variable for the population is between 19.5 and 21.5. Yep, that matches everything. We're just talking about the mean value, and it's between our range, so our answer is A. B. It is not possible that the mean value of the variable for the population is less than 19.5 or greater than 21.5. So yeah, less than and greater than those numbers are outside of our range. But you can never say never, so it's not going to be B. C. Every value of the variable in the population is between 19.5 and 21.5. So this is in between our range, but it just talks about values in general. It doesn't talk about the mean value. That's not going to be C. And then D, the mean value of the variable for the population is 20.5. And that just doesn't even talk about our range, so it's not going to be D. Question number 15. In State X, Mr. Camp's 8th grade class consisting of 26 students was surveyed, and 34.6% of the students reported that they had at least 2 siblings. The average 8th grade class size in the state is 26, so the same as this guy. If the students in Mr. Camp's class are representative of students in the state's 8th grade classes, and there are 1,800 8th grade classes in the state, which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? So we know that 34.6% of the 26 students in this guy's 8th grade class has at least 2 siblings, but we're trying to find those who have fewer than 2 siblings. So if I do 100% minus 34.6%, we get that 65.4% of the 26 students have fewer than 2 siblings. So we get that's going to be equal to about 17. So 17 students in this guy's 8th grade class has fewer than 2 siblings. Now we want this out of the 1,800 8th grade classes. So we're going to have to do 17 times 1,800, which is equal to 30,600. So our answer is going to be C. Question number 16. To estimate the proportion of a population that has a certain characteristic, a random sample was selected from the population. Based on the sample, it is estimated that the proportion of the population that has the characteristic is 0.49, with an associated margin of error of 0.04. Based on this estimate and margin of error, which of the following is the most appropriate conclusion about the proportion of the population that has the characteristic? Oh my goodness, that was a whole bunch of words just to say margin of error of 0.04, which means we're going to be adding and subtracting that from 0.49. So 0.49 plus 0.04 is equal to 0.53, and then 0.49 minus, wait, I did it backwards again, is equal to 0.45. So it could range anywhere in between 0.45 and 0.53. It is plausible that the proportion is between 0.45 and 0.53. That's exactly what this says, so our answer is A. It is plausible that the proportion is less than 0.45. That's literally outside of our range, so no. C. The proportion is exactly 0.49. Once again, you can't be saying exactly. Plus, it's supposed to be in between the range, so it's not C either. And then D, it is plausible that the proportion is greater than 0.53. And that's also outside of our range, so it's not D either. Question number 17. A store manager reviewed the receipts from 80 customers who were selected at random from all the customers who made purchases last Thursday. Of those selected, 20 receipts showed that the customer had purchased fruit. If 1,500 customers made purchases last Thursday, which of the following is the most appropriate conclusion? So we know that 20 out of 80 receipts had fruit, and then we want that out of 1,500 customers, so we're going to multiply that by 1,500, which gets us 375. So let's look at it. Exactly 75 customers must have purchased fruit last Thursday. Can't be saying exactly, so it's not going to be A. B. Exactly 375 customers must have purchased fruit last Thursday. Well, they got the 375 right, but you can't be saying exactly. C. The best estimate for the number of customers who purchased fruit last Thursday is 75. Well, I don't know how they got 75, so it's not 75. And then D. The best estimate for the number of customers who purchased fruit last Thursday is 375. So it says estimate and it says the right number, so our answer is D. Question number 18. In a study, the data from a random sample of a population had a mean of 37, with an associated margin of error of 3. Which of the following is the most appropriate conclusion that can be made about the population mean? So we have our margin error of 3, and we're going to be adding and subtracting that from 37. 37 plus 3 is equal to 40, and 37 minus 3 is equal to 34. That means our range could be anywhere between 34 and 40. Let's look at our answer choices. It is less than 37. Well, that doesn't include our range, so no. It is greater than 37. Once again, not a range, so no. C. It is between 30 and 40. 34 and 40. Yep. It is less than 34 or greater than 40. That's also not in our range, so no. Question number 19. The table shows the results of a poll. A total of 803 voters selected at random were asked which candidate they would vote for in the upcoming election. According to the poll, if 6,424 people vote in the election, by how many votes would Angel Cruz be expected to win? So here, we know that Angel Cruz has 483 votes and Terry Smith has 320 votes. So out of 803 voters, Angel Cruz would win by whatever 483 minus 320 is. So that's gonna be 163. So we know that out of 803 voters, she would win by 163. Now they want us out of 6,424 voters. So we're gonna multiply this by 6,424, which is equal to 1304. So our answer is B. Hello guys, I would just like to say that I'm sorry for assuming Angel Cruz's gender. You know, they could be a he, or a she, or a they, or a Z or Z. Anyways, question number 20. A random sample of 400 town voters were asked if they plan to vote for candidate A or candidate B for mayor. The results were sorted by gender and are shown in the table below. The town has a total of 6,000 voters. Based on the table, what is the best estimate of the number of voters who plan to vote for candidate A? So first, let's find how many plan to vote for candidate A out of these 400. And it's gonna be the sum of this. So 202 plus 34 is equal to 236. So we know that 236 out of 400 voters plan to vote for candidate A. But we want to know the total number of voters for all 6,000. So we're going to multiply that by 6,000. And this multiplied by 6,000 is 3,540. So that is our answer. Alright, that was 20 practice problems on inferences and margin of error. And I think you could tell that this should belong to reading and not math. Because let's be so real, 70% of the problem is reading. Like here you have to make sure that it says 6,000. So you have to multiply by 6,000. And the ones where it says like mean somewhere, like here it talks about the mean value, so you have to make sure your answer choices contain mean value. That's also super dumb, alright? And anyways, just make sure you read super duper close. And oh yeah, this one. Remember that these are studies, alright? And studies are never 100% accurate. So if anything says it's 100% yes or 100% no, that's also not your answer. And other than that, just make sure you're always reading super close and reading the entire question. And that should be it. I'll see ya.